Okay, here's what I've built. Spins really good. Nice and flat spin. And so this thing has the bucking permanent magnets. This gap right there. It's like either north against north or south against south. I showed this in previous video. So now I got the rotor in place, and skateboard bearings each side, and it's going to be going north, south, north, south, north, south, north, south, and I'm going to use this as a tester. I'm going to put various coils in here, one on top, one below, and check things out. Here's a good idea that I have. I take one of these ferrite cores right here. It's ferrite. It's a tube-shaped ferrite core, and I wound toroidal around it, as you see. These are multi-filers, and then I hooked them bifilers, series 18, whatever. But so when this gets a pulse of current, it creates a kind of a blocking field or a shield where the magnetic field of the rotor magnets is blocked by the toroidal coil here, and this is how the Orbo motor works. It'll pull itself these magnets will pull themselves naturally to the ferrite core, and then when the magnet wants to leave, normally the magnet would get pulled back. So it gets pulled to it, and then when the magnet goes past, it gets pulled back, so you don't get anything. But you time the toroidal coil to create its magnetic shield at a certain point when it wants to pull itself back, the rotor magnet. So it would probably be like, okay, so let's say this is it. It gets pulled to it, and then it wants to go past, and then somewhere after top dead center, you cut the power, you give it an impulse, and maybe to about right there is all it lasts. And then it just moves on to the next one, gets pulled to it, and then, so that's the way an Orbo motor works. So what I've done here is I wound these coils, and this fits inside of here. So you can have the Orbo motor spinning the rotor, pretty good rate, pretty good power too. If you have 8 of these on top and 8 of these on bottom all being attracted at once, that's pretty good torque. And then they all get, the toroid in there gets impulsed just at that right time, just after top dead center, and the thing will fly. I've made a few Orbo motors. They work really good. I was noticing on some that the power goes down when the input goes down when you load the shaft up to a point. And anyways, so I have this idea. I have another one of these made like this with bigger coils and bigger cores. And so these solenoid type windings with the blue tape, these will be generator coils. And what's going to be interesting is a toroid coil. The Orbo motor, it doesn't matter if this is north or this is south or this is north or the south. It doesn't matter. It gets pulled to the ferrite core, the magnet does, regardless if it's north or south. So the Orbo will be, if I have 8 magnets on top, 8 coils on top, 8 coils below, the Orbo will be taking a DC pulse to excite the toroid winds right after top dead center, as I explained. And so it'll be like 8 in one revolution, 8 DC pulses. It's all DC to make it go. But now what's interesting is the generator coil around the Orbo motor. This is not going to be electrically connected to the Orbo motor, but it's going to be getting induced AC. It'll be producing AC current from the north-south magnets. So actually, this is going to work like a inverter. It's going to be drawing DC, making AC, and the voltage in, the voltage out will be decided by the winds, and in series or in parallel, stuff like that. Same with the generator coils. So it's possible I could be putting in 12 volts and making 120 volts AC if I run all these generator coils in series, for example. Notice I have them multi-filar, so I can put some in series, some in parallel, or all in series, all in parallel, depending on what you want. A lot of volts or a lot of amps coming out of the generator coils. So that's interesting. It should do something. Also, one more thing, hold on. Okay, where that gap is, you know, there's 2 magnets put together with a bucking at that gap in between. The field extends out longer. It's also a bucking field. So I'm going to put this screwdriver and hold on. Here's a steel file instead. Whoa. I figure I want to make my cores about 7/8 long, 7/8 inch, not quite an inch. Because that's where this thing suddenly wants to pull itself to the magnets. Right about here. But over on that tip, over on this side, where it's not so influenced by the bucking of the 2 magnets together, the field is not as strong, or at least it doesn't go out as far. It's about right there. Now let's say I do it in the middle. It's about 7/8 of an inch up. So anyways, you get the picture. The field extends further where the bucking is. And so it doesn't do much good to make like coils like this long, because the field's not going to even penetrate, except for that maybe 3/4 to 7/8 of an inch. And that's what I have in my dual rotor motor generator. And let me show you that. Hold on a sec. Okay, so here's my dual rotor motor generator. So The motor coil is of this space, it's 45 millimeter. There's a motor coil and a generator coil sharing the same ferrite core. 15 millimeters of that core is wrapped with motor coils. And it puts out a lot more amps if I use the motor coils as generator coils and short them out and test their amps and all that. It puts out a lot of amps, but the generator coils don't, and that's because I have these very thin magnets, only 1.5 millimeters thick, and look at the, like before this will even attract, it's not even, it's about right there. So these generator coils are not being induced very much by these magnets. Now the idea is when I pulse these motor coils, the entire length of the generator coil is going to be induced, working as a linear transformer, you could say. So because it's going to, the whole core is going to induce, and so that's the idea with this. But I want to put much stronger magnets back here, and I'm waiting for some to come in the mail. And another thing I'm trying out is running this whole thing as a motor coil, running the generator coils and the motor coils in series, pulsing the whole thing. And then I want to take out just power from the generator coils, and then take out the flyback back EMF from the motor coils, but take out everything from the generator coils. Did I say that? I don't know. So I'm thinking about dividing the two with diodes, maybe. So I'm experimenting with this, but mainly I want to get bigger magnets back here. Just stack some more on the back end here, so we get the generator coil being induced. And I guess that's about it. So, okay. Thanks for watching.